Hello, friends. This is AI A to Z, and I'm Dr. Sonali Tamankar. Today, we have AI for the Golden Retriever. R is for Retrieval Augmented Generation, or RAG. I highly recommend sharing this episode with your pets. I'm sure they will love it. Jokes apart, I'm really glad we have finally arrived at R. I've mentioned RAG many times already in this series, and today we get to really unpack it. If you're just joining because of the title, RAG is an AI technique that, like your beloved pet, fetches relevant information and lays it at the LLM's feet. This helps language models stay grounded in truth and makes them less likely to make things up. I want to do three things today. First, explain why RAG exists at all. Second, walk through how it actually works. And third, show you some real examples, prototypes I've built myself to make all of this less abstract. I think of RAG as serving two core purposes: LLM customization and grounding. Large language models are powerful, but they can hallucinate. So, providing them with a source of truth or a logical skeleton helps enormously. That's what grounding is, and RAG is one way to do it. Now, what do I mean by customization? Large language models are trained on massive amounts of data. They absorb an incredible amount of general knowledge. But just like even the most brilliant new employee still needs onboarding when they join your company, we often want to customize an LLM to do our specific job better. There are broadly two ways to do this. One way is to customize the model without changing the internal parameters. The other is to actually modify these parameters, the LLM parameters, and change how the model behaves internally. The second approach is like a brain surgery on the model. Methods in the first category are usually simpler. This is where RAG sits. It's like handing a cheat sheet to the model. So let's briefly survey these two categories. The simplest example in the first category is prompt engineering, just asking questions better. Modern models also have a very large context window, which means you can feed it a lot of text directly. In theory, you could paste an entire book into the prompt and ask questions about it. In practice, this gets expensive and slow because the attention algorithm scales roughly with the square of the input length. This is where RAG comes in. Instead of feeding the entire book to the model, RAG just retrieves the relevant pages and injects them as context. Methods like tool augmentation and AI agents also fit in the first category. Instead of forcing the model to answer everything directly, we teach it to retrieve information, call tools, or even take actions in the real world, all without touching the core model parameters. Before getting into the how of RAG, let's take a quick tour of the brain surgery category where we do change parameters. One option is full fine-tuning, where every model parameter can be adjusted. It's like nudging billions of dials. This lets us build models that work better for specific domains like medicine. Parameter efficient fine-tuning tweaks far fewer dials. Techniques like prompt tuning and LORA fit into this category. I've also linked a reference below on representation learning. This work is especially fascinating. It's like doing a brain scan on the model, finding something like an honesty circuit, and then surgically modifying it to fundamentally change the model behavior. But today we are focused on RAG. So, how does RAG work? So imagine that your source information lives in a collection of PDF documents. The first step is breaking those documents into chunks, usually paragraph-sized pieces. Each chunk is then converted into an embedding, basically a list of numbers that captures semantic meaning in a way computers can work with. These embeddings are stored in something called a vector database, and now we are in business. When a user asks a question, you embed the question and then find the chunks whose embeddings are closest to it, often using cosine similarity. That's just math for saying that you find parts of the documents that are most relevant to the question. You take those chunks, attach them to the original question, and then feed the whole thing into the LLM. And then, based on this whole thing, you get your final answer. So, this way, the model generates an answer that is grounded in the retrieved information. So this is great, but RAG is not a silver bullet. It introduces its own failure modes, like retrieval can miss the right information, embeddings can drift over time, chunking choices matter a lot, and the models can still hallucinate even when grounded. So, but the good news is that these problems are usually easier to monitor, debug, and improve than the mysterious model behavior. So, for example, we can combine RAG with keyword search in a hybrid system and so on. Okay, so let's look at some applications of RAG now. So I have a couple of them. The first one is a prototype that I built with a regulatory a compliance team in the healthcare domain. So healthcare regulations are complex and non-compliance can cause harm to patients and serious consequences for hospitals. So this is a great use case for RAG. I started with a set of regulation documents provided by domain experts, broke them into chunks and built a vector store. So when a user asks something like, how should expired drugs be disposed of? The system retrieves relevant passages from multiple documents at once, including, for example, disposal of drug samples. This works better than keyword search. RAG finds semantic matches. So it will find documents with the word medicine when your query says drug. This is something Control F can't do. So the final example I have is a prototype that I built for sickle cell patients. So this is a condition where patients often end up in the emergency room. So I built a risk model first using traditional machine learning. So now imagine the risk model flags two patients as high risk. Patient A is at high risk because of multiple comorbidities like diabetes and hypertension. Patient B is at high risk because they don't have insurance, they don't have primary care provider, and only receive care in the emergency room. So same risk score, but completely different situations, right? So there is a technique called Shapley values that helps us identify these risk factors. This is part of explainable AI, which we will get into in letter X. So, but to really understand what's going on, providers will need to look at patient charts, but these can be hundreds or thousands of pages long, and provider time is limited. So, I built a RAG system that is based off of individual patient charts. So, for example, then the provider can ask a question in natural language like, how many appointments did this patient miss? And what were the barriers? Because I used the patient identifier and the note date as metadata, we could make sure that we only retrieved information for the correct patient. So RAG combined with that retrieved context could help answer clinicians' question to generate an answer. So this is a lot of material we covered today. The details are not as important as the big ideas, which are RAG is a technique for LLM customization and grounding. It works by retrieving relevant information and adding it to the prompt. And it has real world impact, especially when combined with other AI methods. So tomorrow we will be back with supervised learning and with some truly fun applications like training robots. So we are all done for today, and now you're officially free to play with your pet. Bye.